Well, hello everyone. Welcome to From Table to Map. This is a workshop that will show you what to do if you have data in a table and you want to get it up into a map in a GIS. I'm Janet Reyes, the Geospatial Information Librarian here at UC Riverside Library. And a couple of housekeeping things before we get underway. If you are a UCR affiliate, you are probably noticing that QR code in the bottom left corner of your screen. That helps us track attendance for workshops like this. So if you wouldn't mind scanning that code, there is also a link in the chat that will take you to the same place as far as registering your attendance. That's for UCR affiliates only. I know we have some community members who have signed up for this as well, and you don't have to worry about that. Let's see what else. This workshop is being recorded, and in about a week or so, once we get the captions edited and the recording edited a little bit, we'll have it up on the library's YouTube channel, where you can find this workshop and others that I've given in the geospatial series. Let's see what else. If you have registered for this workshop, I have your email address, and because I have it, I am going to send you shortly after this workshop concludes a copy of the slides. And the slides have lots of great links that will help you as you explore this topic further. So yeah, be sure to look in your inbox or your junk mail perhaps for an email from me that has the slides attached. I have an assistant today. Her name is Bella, and she'll be helping me with pasting information into the chat and then also monitoring the chat in case I'm not aware that there's a question and I should pause or something like that. This workshop, it involves using ArcGIS Pro if you wanted to try to follow along. It's not necessary, but if you would like to, I recommend that you have an ArcGIS Pro session open. If you received emails from Eventbrite about this workshop today, there was a link to a folder where you could download the data that we're going to be using in the demonstration. But again, that data will also be available after the workshop concludes, and you could try it on at your own pace, kind of thing. So there's all that. And then toward the end of the workshop, we will have another link in the chat for you, and that will take you to a survey. I know we're all tired of taking surveys, but this one's simple. It has 3 questions. You just get to pick the question that you feel like answering. And then that information will help us understand if we met your expectations today, if you have ideas for other things that you'd like to see, that kind of thing. So real quick, and we'd certainly appreciate your participation in that if you can. I think that is all the housekeeping I have. So with that, we will get started. And this is the UCR land acknowledgement. We'd like to respectfully acknowledge our responsibility to the original and current caretakers of this land, water, and air, the Cahuilla, Tongva, Luiseño, and Serrano peoples, and all of their ancestors and descendants, past, present, and future. Today, this meeting place is home to many Indigenous peoples from all over the world, including UCR faculty, students, and staff, and we're grateful to have the opportunity to live and work on these homelands. So here's our overview of today's workshop. We'll start by just framing the challenge that we're trying to solve. Backtrack a little bit to understand a little bit about attribute tables in a GIS because they're very important to this whole process. We'll talk probably at length, maybe a little bit longer than many of us would like, but about preparing the spreadsheet, the things you have to do beforehand to get this whole process to work. And it involves data cleaning or formatting your table. Then we get to the real part where we're actually doing the things, starting off by creating point locations from tabular data. Then we'll pivot a little bit to adding data that's in our table to features that are on the map. And there's a couple different ways to go about that. One is a table join, and the second one is a spatial join. And then at the end, we have the tricky bits. They're all the little confounding things that you might run into that kind of throw you off. And we'll try to just outline those in general so it doesn't totally throw you if you do encounter them when you're doing this kind of thing on your own. So what is the challenge? You have a spreadsheet, and that spreadsheet contains data about geographic features. and you want to see that data or analyze it in a GIS, but you can't find an existing map that has that data. And in this case, we're looking at a spreadsheet that has flood information by census tract in Orange County, California. That's kind of a niche data set. So maybe nobody else has mapped this before, but you have the data and you would like to do that. So you have that spreadsheet, and you may or may not have a map layer that corresponds to the types of areas or features referenced in the spreadsheet, right? Like maybe you do have a census tract map. So what are the solutions for getting your data up into a map? Well, if you do have that map layer, I mean, in theory, you could copy and paste the data for each location or each census tract into the map's attribute table, one by one. Or if you don't have a map layer, maybe you can create points in the GIS based on the location that's mentioned in the spreadsheet, whether it's a coordinate or an address or something like that. That's very tedious and time consuming. Both of those approaches would be. They work, but they're very time consuming. Happily, there are more efficient solutions, and that's what we're talking about today. So let's backtrack a little bit and understand something about attribute tables in a GIS if we don't already. Attribute tables are associated with the type of data in a GIS that's called vector data. This is where we represent features on the Earth's surface by either points, lines, or polygons. Polygons are another word for areas or shapes. Each of these has to be in a separate layer. So you might have point data, and you might have a different layer in your GIS map that shows lines like roads or streams or something like that, and so forth. But for any type, whether it's points, lines, or polygons, there's an attribute table in the background associated with this layer. And the cool thing about it is that the attribute table contains characteristics of the map features. In this example, we're looking at an excerpt from the campus map from a few years ago for UCR, and we're looking at parking lots. So as you can see, I've got a couple of rows in the attribute table highlighted, and those same corresponding parking lots are highlighted on the map. And you can see there's different types of data we have about the parking lots, whether it's the ID or the spaces, anything like that. So that's the idea. You can have as many columns in the attribute table as you want. And then once you have that in the GIS, you can manipulate the map so that it's showing or displaying what the data is, whether it's by color or size of a point symbol or something like that, from any of the columns. So that's what the power of a GIS is. And let's talk a little bit about what an attribute table has to look like, because it's a very specific need that it has. And this is going to play into how we prepare our data for including it in the attribute table. So each column in the table is also known as a field. And each column contains a different type of information about that feature, including one column that's somehow giving a unique ID for that feature. There are some rules for how the columns have a heading or a title at the top. The first character has to be a letter. You can't have any special characters in that heading except an underscore. You can't have any spaces. Each header must be unique, so no duplicate identical headers, and you can't have a subheader. And within that column, the formatting, whether it's all text or date or numerical, that has to be consistent throughout the whole column. For rows, after row 1, which is dedicated to those headers for the columns, every other row in the table corresponds to a different feature on the map, and no row is completely blank. There can be blanks in certain columns, but the row has to have some kind of information in it somewhere, even if it's just the unique ID. So with that as a background, let's get into how we prepare our spreadsheet for including it in a GIS. And I'm dividing it into two basic facets of how you go about preparing your data. The big one is data cleaning. So they're making sure that the data characteristics match what the GIS needs. And then table formatting. So that data cleaning is involving what's the content of the cells in the table. Table formatting talks about the arrangement of the rows and columns the configuration of the rows and columns in the table, and how that meets what the GIS is looking for. So let's start with data cleaning. And with that, let's start with the different types of geographic data that you might have in your table. So there are 4 basic categories, at least, that I am aware of and can think of. Sometimes we have coordinate information, such as latitude and longitude. Sometimes we have street addresses. Sometimes our table might contain place names, like a political unit, like a county name or a city name. Sometimes even natural features like Lake Superior or Mount Hood or something like that would work. And then the last category is what we're calling administrative units. These are like the workaday kind of maps that somebody needs to have in order to do their job. So like whether it's a census tract or a school district, or maybe it's a utility service area, something like that, where it's not super common to find a map that has this information, but somebody needs it in order to do their job. So we're going to take these categories one by one and talk about some of the ways you might need to clean up that data before it can go successfully into a GIS. And so now we're talking about coordinates, and specifically latitude and longitude. The GIS really likes latitude and longitude. That's what it understands the best, if you would. So it's very happy when it gets a table that has these values in it. But there's still a few things that you might have to do to get this ready. So one thing is to have your latitude in one column and your longitude in another. What you're seeing on the screen here in these boxes, and this is the way some data comes sometimes, where you have the latitude value, a comma, and then the longitude value. We'll need to split those into 2 different columns. And a lot of times we'll see longitude and latitude expressed as degrees, minutes, and seconds. The GIS does not prefer that. It would like it to be in decimal degrees, like we see down here in blue in the second box. So there are ways that you can convert it to decimal degrees either before or after your file is uploaded to a GIS. And whether it's a tool of GIS or it asks you to do this calculation just by plugging it in, the formula to use is there on your screen. So you take the degrees and leave that alone, but then divide the number of minutes by 60 and the number of seconds by 3,600, and you get decimal degrees. And one kind of tricky thing about using latitude and longitude, we always usually speak of them in that order, latitude first and longitude second. In a GIS, we talk about XY values. And in this case, longitude, which is the distance to the east or the west of the prime meridian, that's your X value. And latitude, which is how far north or south you are, is the Y value. So that's kind of backwards. And sometimes it's very easy to get mixed up and put them in the wrong order. So just be aware of that as an occupational hazard when you're dealing with latitude and longitude. The next category of geographic identifiers is address. And most of the GIS platforms have some kind of way to recognize street address locations. This is the process of translating something that's written down as an address into a point on the map is called geocoding. So some of the GISs have geocoders embedded in them, and some of them are quite robust, but maybe they don't cover everything you need. So there are also external geocoding tools that you may need to use in addition to what the GIS comes installed with. And so to improve your chances of getting a correct address placement, here are some things that you can do in advance. One is to create these distinct columns for each component of the address. So as you see in the little example there, one column has the address, one column has the city, state, and zip. So break it up that way. Remove any non-essential text. So for instance, maybe one of these addresses has apartments and you don't need to know unit 13 or unit 15. It's all going to map to the same point. So you can just get rid of that extra specificity about the address. Make sure abbreviations are used consistently within your data set. So I like this example because 3 of our 4 addresses here talk about locations that are on a state route, but they've expressed it 3 different ways. We have State Route 3, we have Route 520, and we have RT, which stands for route. 9W. So we would want to try to get those all standardized so it looks the same format for each of those addresses. And then sometimes, back east, there are zip codes that start with a lead 0. And sometimes our spreadsheets software will try to be helpful and take out those lead 0s. So we need to make sure that they are in for that to work. And then also, sometimes zip codes come with a 4-digit extension. So just make sure it's consistent. If it's all one way or all the other with that 4-digit extension, that'll work fine. And getting a spreadsheet of addresses ready for a GIS can be very time consuming. So just be prepared that you may have to go through it several times of data cleaning to achieve close to 100% match rate, where it ends up where every address on your table is represented by a point on the map. We might have to do a lot of fiddling to get there. So next we're talking about common place names. Like I said, sometimes if you have states or counties or cities or some natural features, depending on the GIS, and I know it works with ArcGIS Online. I haven't confirmed that it works on QGIS or ArcGIS Pro. I have not seen anything that it does work, but maybe I didn't dig far enough for that. But anyway, in ArcGIS Online, it is possible that if you have a spreadsheet that has this kind of information as your geographic identifier, ArcGIS Online will create a point centered in that feature. So if it's like San Bernardino County, it will generate a point that sits in the middle of San Bernardino County on the map. Something to keep in mind that gets a little tricky here is that some city or county names are repeated throughout the United States. Like there are, I don't know how many Springfield, cities with the name of Springfield or Jefferson County or that kind of thing. And without any additional context, the GIS will pick a location that's called that, but it may not be the one that you've intended. So one way to get around that, at least for counties, is to use something called FIPS codes. They serve as a unique identifier for counties. Like the first 2 digits correspond to the state and the last 3 digits correspond to the county name. And that helps avoid those kind of errors of mismatch. And then lastly, we were talking about those administrative units like utility service areas or voting districts or something like that. The GIS is most likely not going to recognize those right away. So you would need absolutely to find a GIS layer that contains those boundaries. And then the data in your spreadsheet can be appended to the attribute table for that layer. The one thing, again, that can come into play is that your spreadsheet software like Excel or something might just want to drop those lead 0s if they exist. So you want to be sure that that is remedied before you add it up into the GIS. And then also the format should also match what the GIS layer is expecting to see. So hopefully that makes sense. Just a little bit of prep work that you need to do, or sometimes a lot. Now let's talk about the table formatting. And this will be a shorter segment of the workshop. But again, this is going to kind of get to the idea that the GIS wants things to look in a certain way for it to work. And a lot of it's mimicking what the attribute table is like. So your spreadsheet needs to have one column for each different type of information. The first row is going to be occupied by column headers, no special characters in the headers, including lead or ending spaces. I had one table I was trying to upload one time and I could not figure out why it wouldn't go. And it turned out that there was an end space after the header title, and it just was invisible, but it was there. And then once I backspaced once, then the table all uploaded. So that can really be tricky. And then again, each header has to be unique. The formatting in a given column has to be consistent, whether it's all formatted as date or numeric or text. Each row represents a different feature, and we should not have any blank rows or subheaders. Some of this may sound familiar or ring a bell if you've done any data management in the past with just regular spreadsheets. And the thing that can come in really handy here is using pivot table tools. Some of the GIS platforms have pivot table tools in them. Maybe you want to use it in the spreadsheet software. If you use Python, it's in the Pandas library. So you might want to take advantage of that to get your table to look the way it should. And my next slide is one of my favorites. This is an actual case where students came to me with a table that looked like the one on the upper left. And what I've just gone through with you, you can kind of see already we've got some issues where there's multiple rows for one county. We've got special characters in the header, like looks like row 2 is kind of serving as subheaders. So we've got a lot going on here. So what they needed to do, the students had to go away and come back and present a table that had one row for Alameda County and all the data strung out in different columns for that county, and then repeat that process again for all the other counties in California, and also rename their headers and stuff. So anyway, that's the kind of thing we need to do to get the table ready. There'll be slides like this throughout the presentation where I just give you some extra resources about preparing the spreadsheet, because what I've told you pretty much scratches the surface. So to get into it a little bit more, you're welcome to access any of these guidances. Or the first thing I have listed under data cleaning is Open Refine, and that's a very popular tool for getting your data all cleaned up and ready to go. Okay, so that concludes the let's prepare our data. Now we're going to get into actually creating points from our tabular data. I'm just going to pause for a second and just see if there's any questions or comments before we go on. Let's go on to looking at uploading tabular data and create some points from it. And the example we're going to use is plotting earthquakes that, in this case, they had a magnitude of 5.5 or greater. And you can see this table has latitude and longitude in separate columns. So we know the GIS is going to like that quite a bit. And this is a very straightforward procedure. So I'm just going to talk you through it with the slides, but for some of the other things we're looking at later, we'll go ahead and I'll cut over to an ArcGIS Pro session that I have set up already. So if you are in ArcGIS Pro and you have the link to that folder, what you'd want to do is download the file that is called database_EQ 5.5 plus. Again, hopefully, if you're trying to follow along right now in real time, you would have an ArcGIS Pro session set up and started. Once you have that going, in the map tab, in the layer group, you would click or try to find that little icon that represents where you add data from. And then in the dropdown, you'll find points from table and then XY table to point. So remember, I was talking about XY and that latitude, longitude kind of thing. So that's what we're trying to do. There's another way to get to this later, like many GIS have different avenues to get to the same place, but I was just showing you this one for starters. So once you click on that XY table to point option, you get an interface that looks like this. What you would want to do is for the input table, navigate to wherever you had stored that table, which is probably in your downloads or whatever folder you've put it in. And then once I have chosen that table, what you'll see is that it will already automatically give it a name for your output feature class, which means the layer that's going to be in the map. And you can change that name later, but that's just what they do for starters. And then you'll notice that it recognized, oh, you have a column for longitude, that's my X value, and you have a column for that's called latitude, so that's got to be the Y. So it automatically populates. And if we had height or depth values, that would be the Z field, but we don't in this case. And so then after that, you would just go ahead and hit run. Sometimes when I have done this, there's a warning that pops up about the output feature class already existing. If that happens to you, you can just ignore that warning. And this is what the result looks like. So I see some patterns here. I don't know about you, about the locations of these earthquakes. But this is something Visualizing on a map is way different from just having rows and rows in a table and not being able to see what the spatial relationships are. And what I've done in this screenshot is just select one of the earthquake points on the tip of of Africa, and just to show you that we can look at the attributes, and for this particular earthquake, we have all the things that were showing up in the attribute table for that particular event. So that was pretty painless. There wasn't too much to do. The table was configured nicely and the GIS knew what to do with it, and it created a map from data that was just in a spreadsheet. So like I said, different GIS platforms have different ways that you go about doing these things. So in the slides, I have a link for how you do this in ArcGIS Online and how you do it in QGIS, which are the two other big, most well-used platforms around for GIS. Okay, so now we're going to get to the part where we have to do a little bit of linking of our tabular data to the mapped features. And we're going to start with what's called a table join. What is a table join, or why do you do it? Well, you do it because you have attributes in your spreadsheet that you want to join to spatial data. And here are some use cases that could be common, like you have election results by county and you have a map of counties and you want to represent those election results on your map of counties. Same thing with, you could have crime statistics for cities. Maybe you're in a research group that's going out and surveying different lakes in the region and you're gathering temperature data and you just want to depict that on a map. So all kinds of use cases where you would want to get something that's in a table up onto a map and be able to analyze it and view it that way. So a little bit repetitive again, but I just want to hammer this home. There are some conditions for a table join to work. The data table, like the one that you have, the CSV or whatever, and the attribute table for the map, they both must have a column or a field, as they call it, that contains the same spatial identifier, whether it's a census tract number or a city name or a FIPS code. And that spatial identifier has to be expressed identically with consistent use of capitals and abbreviations. So New York is a great example, because if my spreadsheet has the words New York in the column and my map in the attribute table has NYC or New York City or New York all in capitals, it's not going to match. It has to be expressed the same way, which pick one to change and change it so that they match is the basic thing to take away here. And also the columns that you're using, that geographic identifier column, that data type has to be the same in both the attribute table and the data table that you're uploading. Again, if you need to make a change and you want to do it in the GIS, I have a link there for how you go about doing that. It's pretty straightforward in ArcGIS Pro. But the good news is that you don't have to make the column headers identical. You can tell the GIS in this table, it's called this, in this other table, it's called something different. But those are the columns that I want you to use to do this table join. So for this demonstration, I have picked data that I got from a website called Kaggle, and it's happiness by country. I don't know if you've heard about this survey. It's done every year, and they just survey people in different countries in the world and kind of have them rate how happy they are and all these different other factors. And I think it's fascinating to see. So I thought it would be fun to put on a map. So if, again, you have access to that folder, the file that we want to download from that folder is 1_ world happiness, so forth, so forth. That's our data table. Now for the map, what we can do in ArcGIS Pro is access what's called the Living Atlas. So what you would do is open the catalog pane, which if you're not familiar with that, you go to the View tab at the top, and you can find an icon that takes you to open the catalog pane. In the catalog pane, you select portal, and then underneath that, you select Living Atlas, that little icon at the very far right. Then in the search bar, you can type world countries generalized. And when you hit enter, it'll give you results that it thinks matches. And this one on top is the one that we want. And what you can do is just grab that with your mouse and drag and drop it over into the map interface. So that's a nice way to get your world country data. And then that's part one. So now we need that CSV that you downloaded. So you can go to the map tab, back to that add data thing we looked at a few minutes ago, and just navigate to where you have your world happiness CSV stored. And then that will add that file to the contents pane. And it's what's called a standalone table. It just makes it a little easier to work with in the GIS. So at this point, I am going to stop the slideshow and cut over to my ArcGIS Pro session, and hopefully this works. If it doesn't, I do have slides that talk about the same thing I'm about to demonstrate. So here's our world countries, that this kind of orangey outline and fill. And if I right click on it in the table of contents and pick attribute table, what I'm going to try to do is find which column would I want to use to match to my spreadsheet. And it seems at first like, well, here's one called country name. That sounds great. Maybe I should just use that. And it's possible that I would want to use that. However, as I was scrolling, I found a lot of things that are like, well, here's American Samoa. Now, that's not a country by itself, but it's affiliated with the United States. And then there's other things like the Azores are islands that are owned or affiliated with Portugal. And there were just so many examples of that. I thought, I'm going to assume that when they did the survey for Portugal, they included at least a few folks on the Azores. So I would rather have that represented in my data than not. So I'm thinking what I'm going to use is affiliated country as my column in this attribute table for the match. I'm also going to just right click on my standalone table and open that up. And you can see that there's something called country name, and there really isn't anything else here that would even come close to being something I could use as a geographic identifier that would match the layer I have. So I'm going to use country name here for sure. One thing you might want to see is that here I have 143 rows in my table, but in my world countries table, in my world countries map rather, I have 251. So I know there's going to be a lot of countries that are not represented in the survey and are going to end up kind of being like a null value on my map. But you have to do what you have to do, right? So I'm going to close both of these tables now. And what I'm going to do is right click on my world countries layer, and I'm going to pick joins and relates, and then I'm going to pick add join. When I do that, this interface shows up. So because I right-clicked on this, it already knows I want my world countries to be the input table. That's what they call it in this case. And then I have to pick which field or which column in my input feature I want to use for the matching. And like I said, I'm going to pick affiliated country rather than country name, just to get a little bit more territory on the globe represented on my happiness map. Once I did that, this automatically said, hey, you know what? I bet you want this standalone table to be your join table. But if that wasn't true, you have a drop down where you can navigate to some other table that you have somewhere else. If they're using this table, then they already said, hey, I bet it's going to be the country name column that you want to use for your join field. And in this case, they are correct. That is what I want to use. There are some options here about keep all input records and index join fields. I'm going to talk about both of those things a little later on in the tricky bits. But for now, we are not going to mess with those. I also want to point out this validate join button. What that does is start running the process of creating this join. I'm not going to do it now because I don't want to stress out my little laptop here that I'm presenting from, but I will show you on a slide what the validate join looks like. It's a really good idea to do it because it'll tell you whether your process as it's set up right now is going to work the way you think it should. And you can maybe stop in and back up and try something else if it's really not finding hardly any matches or something. But I happen to know this will work. So I'm going to click OK. And now if I open this world countries generalized layer, open the attribute table for it, I still have those world country things, but now I also have the data from the happiness spreadsheet all appended there. And this ladder score is the one that corresponds to the relative level of happiness in that country. So what I have done is from before, I symbolized the darker green shades represent the happiest countries, and the lighter would be the least happy countries. And you can notice, like, Russia did not participate in the survey. A bunch of countries in Africa, we have some holes in South America as well. But basically that gives you the idea. Like before I didn't know, I just had a table that had these values, but now I can see on the map where these countries are and their relative levels of happiness. So let me go back now to the slides. And like I said, I have the slides layout pretty much what I just did. So we compared our two tables that are involved and chose which column we wanted to use for the match. We went ahead and right-clicked on world countries and did the add join process. Now here's what it looks like when you start to run that validate join. It takes a few seconds, but it just kind of tells you what it's doing, and then it tells you what the results it's getting are. And then you can decide to actually go ahead and run it, or maybe like, oh, I better fix something because this doesn't look right at all. Yeah, and then like I just showed you, we opened up the attribute table for the country layers, and we now have that ladder score, which represents happiness, tagged, and then you can symbolize it however you wish. So again, we talked about table joins in ArcGIS Pro. I've got some resources for you if you want to try it in ArcGIS Online or in QGIS. Okay, so now we're going to move on to spatial join. What's the difference between a spatial join and a table join? Well, a spatial join is when you want to add attributes from one layer to another layer based on their spatial relationship. So for instance, if you have a spreadsheet that had reported crimes and you could upload it to the GIS to create a point layer, and you have a polygon layer that has neighborhoods, you can find out how many crimes were reported in each of the neighborhoods. You can kind of go the reverse direction too. So my second example there is maybe you have a spreadsheet with coyote sightings that had latitude, longitude. You were able to upload it to the GIS. Now you can assign which district that coyote sighting was in to the table that had the coyote sightings in it. And it doesn't even have to be like this thing is right on top of this other thing. For instance, if you had a table of information about recreation centers in a big city, and you had a line layer in your GIS that represented mass transit lines, you could do something, set it up so that the identity of the closest mass transit line would now be added to the table that has the recreation center data. So pretty cool stuff that you can do. And we're just going to take a couple of examples with a different set of data, not happiness now. I was able to find data about potholes that were reported in the city of San Diego. And I also found a map of council districts, because I thought maybe the council members would want to know how well they're doing compared to all the other districts as far as number of potholes reported in their district. So again, if you have access to that folder for these next two exercises, we're going to go and get that council district zip file. That contains the spatial information that you're seeing here. What you would have to do is once you've downloaded it, you would have to extract the data to a separate folder, and that's how you can get it into the GIS. Yeah, you would, in your catalog pane, you would navigate to your unzipped folder, and then you can just drag and drop the file from the catalog pane into the map pane, and that will display something that looks like this. You can also download the table that has the pothole requests, which is crowdsourced, like the public wants people in the city to act and fill in these potholes. So it's a whole spreadsheet that has that kind of request information. So you get that from the same folder. Again, they're all of these data sources are in the same folder. Then on the map tab, you can go to that add data icon and click it and navigate to that CSV, and that becomes a standalone table again. You can, yeah. And then you would use XY table to point to get those data points, those data rows onto your map as points. I'm going to cut away back to ArcGIS Pro here to show you this. So I've done some symbolization, so it's not going to look like this when you first get it set up, but I wanted to have all the districts look individually identifiable, and I made my point symbols a little bit smaller than what you would have. And then what we're going to do now is I'm going to try to summarize. I wanted to show you first, if I did that XY table to point, sometimes it takes a while. And I chose my trimmed CSV. In this case, kind of like what we saw with the earthquakes, it knew what to do with a column that's called LAT. That's a common enough abbreviation for latitude, but it didn't know what to do for the X field. And it's letting me pick what I'm going to do for that field. And here are the column headers. And the thing is, for this data set in the potholes, they used LNG as an abbreviation for longitude, and the GIS was not like, I don't know what that is. So you can just go ahead and select longitude there and populate it, and then go ahead and hit the run, which I've already done, so I'm not going to do that right now. So what we're going to do is go over here to my district layer. I'm going to right click, choose joins and relates. But now I'm going to do add spatial join rather than add join like we did before. And it's recognizing, do you want to join, this pothole request CSV, that thing that you have? And that's what I want to do. For right now, I'm just going to open this up and show you that these are all the columns in that pothole request spreadsheet. There's quite a lot of them, and I really don't need hardly any of these for what we're going to do, because what we're trying to get is just a count of how many pothole requests there were in each district. We're not going to have all this other information, or we don't really need it. So what you can do is just eliminate any columns that you don't really need to carry over into the joined result. So anyway, we'll close that up. And if I click OK, it'll run. And then if I open my attribute table, I now have this column that wasn't there before that's called join count, and that represents the number of potholes in each of these council districts. So that's how that works. Now we're going to use the same data, but I've got it set up on a different map. And what I'm going to do is add to the spreadsheet of potholes which council district that particular report occurred in. So that might be helpful information. So now instead of clicking on my spatial layer, I'm going to click on my polygon layer, I'm going to click on my point layer that I derived from my spreadsheet, go to joins and relates, go to spatial join. It already exists. Oh, I did this before, but you get the idea that it would just be, you select your points first and then add to the, oh, I know what to do. Let's go with this one. That works. Yeah. Yeah, and here's an example of where I have already eliminated a lot of the fields that I didn't really need to add to my pothole data. So anyway, I'm going to click OK, and I've already done that. And then we're going to see that if I open the attribute table here, way at the end, there's now a column that tells me what district each of these pothole reports are in. So hopefully that makes a little bit of sense, at least gives you an idea of the power of what you can do here. I'm going to go back to the slides now, and we will continue on. Again, these slides just cover what I just demonstrated. So you could try it again at your leisure once you get the slides or watch the recording. Then in the first example, we saw that we had now a new column in our attribute table that tells us the number of points or potholes that were in that district. And then this is the example that we did at the very last, where we were adding district identifiers to our pothole data. So now that we've uploaded some of our tabular data and made it into a map, maybe we want to take that attribute table that we've created and take it down from the GIS and just keep doing stuff with it, right? And the way you could do that is exporting the attribute table for the layer that you created, or any of the layers really. And the way to do that in ArcGIS Pro is to, once you open that attribute table, go to the upper right corner, you'll see like a menu button here. From that, you can choose export. In the output table interface, you navigate to where you want to save that table. You can name it something different and add the extension for the way you want to save it, like whether it's a CSV or Excel or something like that. Continuing on with the export interface, here you have the option, if you want, you can filter what comes out, like just give me the features that correspond, that have this value in this column kind of thing. Or you can also filter the fields, like I don't need to download all 37 fields I have, I just need these 6, so you have a chance to eliminate the fields you don't need. That kind of thing. You can sort the order of the fields before you even download it. So that's kind of nice. And then you can be off on your merry way. Now that you've got this spatial data added to your tabular data, you can continue using it as a tabular file. So again, spatial joins, you can do them in other GIS platforms, including ArcGIS Online and QGIS. And there's some guidance for you to understand how to do that. All right, we're wrapping up here. We're going to wrap up with the tricky bits. Hopefully this won't be too confusing, but it just gives you some exposure at least to some of the things. So you might have noticed when we were doing the demo, we right-clicked and then it said joins and relates. And you might have been wondering, well, what's a relate? Why is it here in the same menu as joins? It also deals with tables that are external to the GIS, but in this case, it's just establishing a relationship, but without appending that data into the attribute table. And that's really helpful when you have lots of data associated with a particular feature in your GIS, and you don't want to clog up your attribute table with hundreds and hundreds of columns. So for instance, maybe you have a GIS that includes office buildings in a big city, and you have a spreadsheet that talks about who the occupants are of this 12-story building. You can just have a table that the user can click on and they can see that, and then they can, just get that information, but without having it embedded in the GIS, so to speak. Same idea, like weekly sales at each franchise location, so forth and so on. So that's a relate. It's less permanent, and it doesn't clog up the works of the GIS quite as much. There are some tools with similar names and functions. Again, this is ArcGIS Pro, is the example I'm using. What we did was an add join, which is quick and it's temporary, but there's that option to make it permanent. I don't know if you remember, I pointed out that checkbox that allowed you to do that or to uncheck it. And then there's a tool called Join Field, which is you access it as a different way. It also does table joins. It makes them permanent right off the bat, and it makes it a little easier to select the fields that you want to exclude from the joined result. Similarly, what we did was add spatial join, but there is a tool that you access elsewhere called Spatial Join. It also makes things permanent, and it gives you more options on how to perform that join. So if you have done the way we did it today, where it's the temporary join, but you decide later you want to make those changes permanent, what you can do is in the GIS export the resulting layer as a new feature class. So then you basically would have the map that represents the data that you had at the start, and then also this new one that has the added stuff to it. And you do that by exporting the result. Sometimes when you do a join, you'll get a warning about field indexing, like this would work better if you would index the fields. And this is especially helpful with very, very large data sets. Basically what it means is, like, maybe you have 3,000 rows in your table, and in this one column there are 52 different values that it could be populated with. So what indexing does, the GIS will just assign the number 1 to the first one alphabetically, and then number 2 to the second one, and so forth. It just makes the process go faster for the GIS. So if you are getting nervous about that, or you think, you know what, this was terrible, I had to wait for 5 minutes for my results, maybe I should go ahead and index it, there is this add attribute index tool, and then you can try running the join again. You might see things mentioned in the literature, or maybe you've dealt with this if you've done any database management or something in the past. What's the difference between an inner join and an outer join? An inner join, it'll only keep the features that have a match, where the outer join, it keeps all features in the output, regardless of whether or not there was a match in the join process. So what we just saw today in both the table and spatial joins, outer join, which means you keep all the stuff regardless of whether it matched or not, that's the default. But you can uncheck the box for keeping all input records, and that's in a table join, or keeping all target features in a spatial join, and then you would have an inner join. So lots of words, lots of jargon. It's a little confusing, but that's basically what happens there. And then you might also see mention of one-to-one versus one-to-many, and both of these, in this context, apply both to spatial joins, where if you have a one-to-one join, that means you have multiple join features for one target feature, and that's the case we had with our potholes, multiple potholes for one council district. So in that case, we generated that column that had the count for how many potholes were in that district, but we did not have all the information about every single pothole report, right? If you do a one-to-many in a spatial join, same situation at the start, multiple join features, one target feature, but in a one-to-many, the target feature will be duplicated. So maybe you'll have 72 council district 4s situated one on top of the other in the GIS, but each one will have the attributes of each of the individual pothole reports. So I can't envision a way or a situation where you'd want that, but I guess some people do. So you do have that option if that's kind of what you're looking for. Lastly, if you're doing spatial joins, something to be aware of is I have to talk about projections a little bit. The Earth is curved, and there's different ways to translate what's on the curved surface of the Earth to a flat screen or flat piece of paper. These are called projections. The data that you find to use in a spatial join may be originating in different projections. The GIS will do an on-the-fly to match the second data layer to the projection of the first one, but that doesn't really work too well. It looks okay visually, but it may not work well when you're doing analysis or things like spatial joins. So basically what you want to do is take the steps in the GIS to change the projection of one of your feature classes. And there are tools that allow you to do that. And I've given you a link to more guidance on that. So that might be something that comes up for you. And yeah, here are the resources that pertain to some of the things I talked about regarding the tricky bits. There's lots more that gets trickier, but I think this is good for starters. So you're welcome to check these out. And I provided the data for today's workshop in a Google folder, but if you wanted to trace back to where I got the data from to use it, like some of it I pared down a little bit, here are the links for you to trace your way back to where that was all coming from. So that concludes the workshop. I thank you for your attention. I hope this was a little bit helpful. I'm seeing a question that just popped up. Could you read that one to me, Bella?
Can you still do a query if you relate two tables?
Ooh. I'm going to say I'm pretty sure that is possible, but I don't know for sure. But it seems like the GIS should have the ability to do that. So I'm sorry I can't give you a definitive answer, but my guess is that yes, you can. You're welcome. Are there any other questions? I know that was a lot of information. Hopefully it'll make sense maybe after a little bit more sense after you review it, but here's my contact information if you want to reach out and ask me any questions after the fact. Again, I appreciate your attention today, and yeah, hopefully we'll see you again some way, somehow. Thank you so much.